Hello class, welcome back. Thanks for sticking around. I'd like to thank everyone that's actively volunteering in these activities I've been setting out. If you haven't been, maybe take that opportunity and try another one. Again, they're not required. It's just one of those things I think it's important that you continue your education. So try to send out a couple different things a week. Today what we're going to do is we're going to do part 3 of week 4, where we go over the Google form answers. So I think it's kind of important. So let's jump right into the iPad and kind of take a look here. So here's our topics today. We're looking at part 3 again, where we're looking at antiderivatives, but we're finding the area between objects. So it could be a curve and a line. It could be two curves. It could be maybe two different lines, but we're finding the area in between it. So the trick is to figure out which one's on the top and which one's on the bottom, so that way we know which order we need to subtract. Because the best way I can explain this, let me kind of demonstrate here. If you had this curve, okay, and you could find the area underneath it. That's what an integral is, right? The area underneath the curve. And I'm going to switch a color up here. And you had a different curve, and you found the area underneath that one. If you subtracted them from each other, like you took the top curve minus the bottom curve, so you're taking away the bottom curve, you'd be left with the area left over, the area between them. Because, again, this is where that other curve was. So this, what you found, was the area directly in between them. That's this part right here. And that's what we're doing. So you really have to kind of figure out, okay, which graph's on the top, which graph's on the bottom, subtract the bottom one off, and that should give you the final area. I know that's tough, but again, these are kind of the things we were doing right before the end of the third quarter here, and I thought it was kind of important that we review this. So let's jump right in here. Let's do the first one. I got 3 problems picked out here, and so we're going to look at the graph of each one, and then we'll go back and do the actual mathematics for it. I think that was kind of the format that I did on Monday for the actual review of this stuff before I gave you the Google form. So we're going to stick with it. These are the 3 problems from the Google form. So the first one here is you have a curve at positive 6, so 1, 2, 3, 4, 5, 6, and it's a quadratic and it's facing downwards. Okay, like that. And then the other one is a line at positive 1. I'm going to switch up a color here. Let's go positive 1. And it's going up 1 over 1, up 1 over 1, up 1 over 1. So here's what we have. And we're finding the area from 0 to 2. So we're finding the area between them. So I'm going to try to highlight this. This is what we're trying to find. The area directly between the two. And yes, there was just a little sliver there. But again, this is the area between the two. So now it looks like on this particular problem, the parabola is on the top, and then the line is on the bottom of it. So that's important that we know that. So we're going to find the area of the curve first and subtract the area of the line. And that should give us what's left. But again, the best way I can explain it is that you're finding the area under the curve, and you're finding the area under the line. And if you take away the area from the line, you're left with just the area between them. That's the idea. I know it's kind of tough to explain that, but I think hopefully that makes sense to you. All right, so let's jump right in here. So let's do the actual math, the real math that's involved here. All right, so again, you are going to find the area of the parabola first. I think that's important, and then we'll find the area of the line, and we'll subtract the two later. All right, so we're going from 0 to 2. That's my boundary of 6 minus x squared dx. So this is the area of the parabola. Now, if we do this, we have to do the antiderivative of the power rule. Add 1 to the power, divide by the power. Add 1 to the power, add 1 to the power, divide by the power. And we're going to evaluate from 0 to 2. Again, we plug in the top boundary first into both. For some reason, it will not let me write that 3 there. Okay, that's weird. And then we're going to plug in the lower boundary, and we're going to subtract that. So if we plug in the lower boundary, that's 0 minus 0, so that just goes away. So that's the lower boundary. It's nice when it's 0, because then it just goes away, so that's just gone back here. So this, again, this is just the area under the parabola. So what we have here, we have 12 minus, now that's 2 to the third power is 2 times 2 times 2, which would be 8 divided by 3. On a calculator, 8 divided by 3, that's a weird number. It's like 2.6 repeating. So if we do this, so if we take 12 and we're going to subtract 2.6 repeating. If I just type this in, it's roughly 9.3 repeating. All right, so there's the area under the parabola. And I'm going to switch up the color here. Now we're going to do the area from 0 to 2 for the line, x plus 1 dx. Now this is my final answer. This is the area under the line. So the power rule again, add 1 to the power, divided by the power, add 1 to the power, divided by the power, and evaluate from 0 to 2. So if I plug in a 2, 2 squared divided by 2 plus 1 times 2 to the first power divided by 1. And then if we plug in zeros, we get 0 plus 0. Okay, there we go. So plug in the zeros into both. Okay, so what we have here, this obviously this part goes away. So we're going to have 4 divided by 2, which is 2 plus 2. So again, this is 4 divided by 2 plus 2. So it's 2 plus 2, which this total area is 4. So that's the area under the line. So if we subtract, so this is the final answer now, the parabola area minus the area of the line. And we should get 5.3 repeating. Again, 9.3 repeating on a calculator. And then you're going to subtract 4. You should get 5.3 repeating. And that's the area between them. So that was what that graph up here represented. Okay, so that was the first one out of the 3. Let's go to the second one now. So again, we're going to graph again. So again, you got to figure out which graph is on the top, which graph is on the bottom, figure out the areas of each, and then subtract top minus the bottom one. That way you can figure out the area directly in between the two. Again, it doesn't matter what they are. They could be both lines, it could be one line, one curve, or both curves, doesn't matter. So, but the problem is graphing them. You got to remember how to bring it back into the iPad. And let's keep going here. So we have x squared, y equals x squared, so that's starting here, and that's a normal parabola going up. The other one is a line starting at positive 4. I'll draw this in a different color. Let's go blue. So we're going to start at positive 4, and then it's dropping to running 1, dropping to running 1. All right, so there is my line. So that's this line. And we're going from 0 to 2 again. So I'm going to try to color this in. From 0 to 2, so this is the area that we're actually looking at. It's that part right there. So it looks like on this one, I know this is going to seem weird, it looks like the line is technically on the top of the parabola. So the line is the top part from 0 to 2. I know that it dips a little bit below, but it'll be taken care of as we go through this. So, all right, so let's jump in and let's do the math here. So the line itself from 0 to 2 is the top. So negative 2x plus 4 dx. So we got to find that area first. So that area is the power rule. So we add 1 to the power divided by the power. Add 1 to the power divided by the power. And we're going to evaluate from 0 to 2 again. So that's kind of nice. We're going to plug in the 2. So 2 squared divided by 2 plus 4 times 2 to the first power divided by 1. And if we plug in 0, 0, and 0, blah, 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 that's all zeros back there. We don't really care about that. So we're going to get, what is that, 4 times a negative 2 divided by 2. So we'll get a negative 4 there. And we're going to be adding an 8. So we should get an area of 4 there. So it's negative 4 plus 8. So it should be 4 for the area. So that's the area underneath the line. Switch up the color here. All right, so now we're doing the parabola from 0 to 2, x squared dx. All right, so add 1 to the power, divide by the power, and we're evaluating from 0 to 2. So this one's pretty easy. We just plug in 2 to the third power divided by 3, and then we're going to be subtracting if we plugged in 0, which 0 would be 0. So 2 to the third power is 8 divided by 3. I think we did this one earlier, wasn't that? Just 8 divided by 3, wasn't that 2.6 again? 2.6 repeating. Okay, so there's the area under the curve from 0 to 2. And so the final thing is to figure out the final area. So the final area is where you take the line area and subtract the curve area. So 2.66666. So if we actually do this, this will be the final answer. That's the exact answer if you want to write it like that. But again, 4 minus 2.666666 repeating, this would end up being 1.3 repeating if you wanted to know what that number is. And that's the area under the curve, or sorry, under the line between the curve. All right, let's go to our last problem here. So we have one arc of sine and we're going to be above the line of half. So, okay, so the line of half is, I'm going to maybe stretch this out. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's say this is the number 1, because I can label this graph however I want. So this is positive 1. So this would be the halfway point. This would be 0.5. And so I'm going to kind of go by maybe by fourths. That's what I'm doing here. No, actually, way more than that. Eighths, maybe. All right, so this is the line for half. All right, so this is the line, and we're going from one arc of sine. Now, why I'm stretching this out? Why I'm not going, because this graph would be really compact. Because the normal sine graph only goes up to 1 and -1, and it has 4 hash marks across. Normally it's 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. All right, so normal sine graph does something like this. All right, so it looks like it's going out to pi. So that's, 3.14. So I'll just I'll jump. I don't want to go by, the eighths like I did earlier, or whatever that crazy number is. So maybe I'll jump every 4 markers. Can I still do that roughly about the same? Yeah, that'll work. Okay, I can roughly do the same. Okay, so the idea is that this is 1, this is 2, this is 3 on a normal graph. I know that the x and y axis aren't lined up, but that's fine. And so I'm going out to 3.14. That's pi. This is 1 arc of sine. So that's where it's going to end up at. So sine is going to start at 0, go up to positive 1, kind of right in between, and then come back down to 3.14. So it's kind of looking like this. So there's the arc for sine. And the line itself is 0.5. That's this line. It's a horizontal line at 0.5 for the y-axis because it's only hitting the y-axis. And so the area between them would be this part. That's the area between them. And so now there would be a little bit extra over here. There would be a little bit extra over here, as you can tell. But that's the area between, the arc and the... so it looks like on this one, the sine graph is on the top. The actual line is on the bottom of it. And so we're going to be doing the sine first and then subtracting the line second. And that should give me the area that I have marked in green here. So let's jump right in here. So 1 arc of sine. So we're going from 0 to pi because that's 1 arc. That's 1 arc for sine. That's what we looked at earlier for sine. Now the antiderivative of sine is negative cosine. Now how I know that is if you take the derivative of cosine, it would be negative sine, and the 2 negative signs would cancel. So it would end up being this again if I took the derivative. So that's the idea. That's how I know. I can always double check. And I'm going from 0 to pi. Now, when you do these, you actually have to plug in both. It's not going to just be easy where if I plug in a 0, it just, works out to be 0. It doesn't work that way sometimes. Now, again, on your calculator, make sure you're maybe in radian mode because we are going to be plugging radians. We're plugging in pi, which is a radian measure. All right, so we're evaluating negative cosine at pi, and then we're going to evaluate negative cosine at 0, and we have to subtract those. Again, upper bound minus the lower bound. That's what I'm doing here with the same function. Now, cosine of pi on a calculator, I believe, yeah, so this should be a -1. So cosine of pi is -1, and there's also a negative sign in front of it. And then over here, cosine of 0. That would be 1 with a negative sign in front of it. So this cosine of 0 is 1 with a negative sign. Cosine of pi is -1 with a negative sign. So these 2 negative signs cancel out, so this is positive 1 in the front. These 2 negative signs here cancel out, so it's positive 1. So this actually ends up being an area of 2. I think we've done this enough times, you probably already knew that. Now, for the next one, we're doing the line y equals 0.5 dx from 0 to pi. So again, we add 1 to the power, so x to the first over 1, and we evaluate from 0 to pi, because there was no variable, so you had to add a variable in. That's how the power rule works. So plug in pi, so 0.5 times pi to the first power divided by 1, and then if I plug in 0, it'll just be 0. So this ends up being just 0.5 pi or half pi. So that's the lower bound. So the final answer is if you take the upper bound and you subtract the lower bound. This would be the exact answer. Now, if you want to know what that decimal is, 0.5 of pi is 1.57. So 2 minus 1.57 roughly is about 0.43. So that's the area between them. It doesn't seem like a lot. There was you know, the graph was definitely exaggerated. If I go back to that last graph, definitely an exaggeration. Sorry, it was just I'm kind of proving the point. We're trying to find the area. There's not a lot of gap there. Sorry. So again, thank you for all those who are actively participating. I have a select few that are really doing it almost every week. Again, they're voluntary. It's not required. But again, first priority is your health, your family's health. That's, you know, I can't stress that enough. It's important. Family is and your health. But again, I miss you guys. I know maybe you guys are enjoying this time off. Maybe you're not. But I do miss class. I do miss, you know, the interactions we have. But again, I hope to see you guys real soon. But again, take care of yourself and take care of your families.